The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. When you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. Today we go on to section 7.7. And tonight the assignment is 7.7 along with the chapter review. We'll review for the test tomorrow. And then the next day you will just take your chapter test. But before we do any of that, are there any questions from over the weekend on section 7.6?
So I don't have a question regarding that assignment, but I did have a question about how the assignments are on Cengage, because on mine it says that we were supposed to do this assignment today and then 7 tomorrow, and then the review on Wednesday, the test on Thursday. Is that not right?
Okay, so do you ever look at your syllabus that I sent out?
Yes,
Okay.
I have it printed.
So what we've got, for instance, yesterday's assignment was 7.6. Okay.
Okay.
The idea is that you do it the day we talk about it in class. Now, if you can't get it all finished because you have some questions, you can come back the next day, as in today, and ask questions about it so that you can get it absolutely finished by tonight. So
Okay.
technically 7.6 is yesterday's assignment. You get a whole day to get it finished so that you have an opportunity to come back and ask questions. Does that make sense?
Okay, that makes sense. So
Yeah.
there are assignments that are assigned over the weekend.
Yes.
Okay.
Friday's assignment is assigned over the weekend.
Okay. Okay.
Yeah.
Thank you.
You're
That makes
welcome.
sense.
You're welcome.
So basically just follow the syllabus.
Exactly.
And I'll be on the right track.
Exactly. What
Okay.
a lot of people do though is they think that they just wait till the last minute. And the problem with that is that if you wait until tonight at 10 o'clock to do 7.6 and then you have questions, well, it's too late because I went to bed.
That makes sense. Okay, thank you so much.
You're welcome. So with that said, is there anything from section 7.6?
No, I didn't have anything. Thank you.
Okay, then we'll go on to section 7.7. First thing I want to do is to make some tables with some given information, and then we'll fill in the missing information. Okay. It's going to take longer to make the table than it is to do the problem, but such is life. Okay. Let's see, this says snowmobile, and this is a 4x4 truck, and this is 4 and 3. This is R and R minus 5. Okay. Actually, let's go to red. All right. So this table is based on the formula distance equals rate times time. Okay. What we're going to do is we're going to fill in the missing times in the table, but we're going to fill them in terms of what is already given. Now, if distance equals rate times time, or D equals R times T, if we want to solve for T, we would divide both sides by R. So that means that time equals distance divided by rate. So in the table, time equals distance divided by rate. In the table, time equals distance divided by rate. Any questions about what I did there?
No.
All right. Then let's go on to another table. And here, let's see. There, there, and I-R-T. Okay, so this says City Savings Bank, and this says Credit Union, and we have I equals P times R times T. Here there's a 50 and a 75, and the time is a 1 and a 1, and the rate is an R and an R minus 0.02. Okay, so I equals PRT. That's the simple interest formula. I stands for interest. P stands for principal, the amount you either deposit in a savings account or you borrow. R stands for the annual interest rate, and time stands for the number of years the money is left in the account or borrowed from the account. But I need to fill in the table for P. Well, if I equals PRT, if I divide both sides by RT, I get P equals I divided by RT. Okay, so P equals I divided by RT. So P equals I divided by RT. Well, R times 1 is just R. Okay, and then the second row there, P equals I divided by RT. 75 divided by R minus 0.02 times 1 is just R minus 0.02. So again, we've solved the formula for the letter P and then written P in terms of I, R, and T. Any questions there?
No.
All right. Let's review some basic converting from decimals to regular number, excuse me, from decimals to percents and from percents to decimals. If I were going to write 9% as a decimal, how do you write that? Do you remember?
0.9.
No. 0.09. You call it 9% is 9 per 100, which would be 9 hundredths. Okay with that?
Yes.
All right. And then how would you write 0.035 as a percent? Ah. See if I can write that a little bit more legibly. Let's see. So 0.035, what would that be as a percent?
Is
35.
it 35 over 1,000?
Okay, that's just what's right here. That's still not a percent. (3.5%).
How do you know how many spots
Yes.
to the decimal?
Think of it this way. 0.035 isn't 100% equal to 1.
Yes.
So I could take 0.035 and I could multiply it by 100% over 1. Because if 100% equals 1, then 100% over 1 is like 1 over 1. And I can multiply something by 1. What does the 100 do to the decimal point? It moves it 2 places to the right, and then you've got a percent sign. There, we just reviewed an entire chapter of Math 75 in one problem. So 0.7 would be 70%. 0.07 would be 7%. 46% would be 0.46. You okay with that?
Yes.
Yes.
All right. New situation. I'm going to read the entire problem and then we'll go back through it piece by piece. If a number is added to the numerator of 5/7 and twice as much is subtracted from the denominator, the result is 8. Find the number. So they want us to find the number. How about if we call it X? Okay, so we're going to call the number X. If a number is added to the numerator of 5/7, okay, so I've added X to the numerator of 5/7, and twice as much is subtracted from the denominator, the result is 8. Let me read it one more time. If a number is added to the numerator of 5/7 and twice as much is subtracted from the denominator, the result is 8. Find the number. Okay, any questions about the equation that I created?
No.
So here we have an equation with fractions, okay, or a fraction. So we're going to multiply both sides by the least common denominator in order to clear the fractions. So we'll multiply both sides by 7 minus 2x, okay? On the left side, those will reduce out, giving us 5 plus x. On the right side, we'll distribute, getting 56 minus 16x. Okay? Any questions? This is a first degree equation, so I will solve it. I'm going to put all the x's on the left. So I'll add 16x to both sides of the equation, giving me 17x plus 5 equals 56. I will divide, oops, I won't divide. I'll subtract 5 from both sides of the equation, giving me 17x equals 51, which I'm going to write up here. Divide both sides by 17, and I get x equals 3. So find the number 3. Let's check our work. If we add 3 and subtract 2 times 3, we get 8 over 1, which is 8. So it checks. So the number is 3. Any questions about that particular problem? Okay. We're going to look at another problem. Again, I'll read the entire problem through once, then I'll go back and we'll set things up, and then I'll read it again so that you can make sure that you understand where everything came from. It says, fast cars. The top speed of a Dodge Charger SRT8 is 33 miles per hour less than the top speed of a Chevy Corvette Z06. At their top speeds, a Corvette can travel 6 miles in the same time that a Charger can travel 5 miles. Find the top speed of each car. Okay, this problem involves speed, distance, and time. Speed, it says 33 miles per hour less than the other, top speed, blah, blah, blah. One can travel 6 miles while the other travels 5 miles. There's your distance in the same time. So you've got speed or rate, distance, and time, okay? Recall that distance equals rate times time, okay? So distance equals rate times time. Okay. And I've got the Dodge Charger and the Chevy Corvette. Let's call them the Dodge and the Chevy. Okay. So Dodge and Chevy. Any questions so far? All right.
No.
The
Thank
top, yes, the top speed of a Dodge Charger is 33 miles per hour less than the top speed of the Chevy Camaro. So if the Chevy's top speed is R, the Dodge would be R minus 33 miles per hour. You okay where I got that?
Yes.
At their top speeds, the Corvette, which is the, let's see, that's the Chevy, can travel 6 miles in the same time that the Charger, the Dodge, can travel 5 miles. So the Chevy travels 6 miles in the same time the Dodge travels 5 miles. Do we know anything about the time? Yes, we do. It said this. It said, let's see here. At their top speeds, a Corvette can travel 6 miles in the same time that the Charger can travel 5 miles. So what do we know about their times?
They're the same.
They're the same. I'm going to put a little sideways equal sign here just for a moment. Okay. Now, I know that distance equals rate times time. Okay. So if distance equals rate times time, but I want to solve for time, wouldn't time equal distance divided by rate?
Yes.
So for the Dodge, the time would be the distance, 5 divided by the rate, which is R minus 33. For the Chevy, the time would be distance, which is 6 divided by the rate, which is R. But we know that the times are equal. Therefore, 5 divided by the quantity R minus 33 equals 6 divided by R. Do you see how we got our equation?
Yes.
All right. We're going to clear the fractions. What would the LCD equal for this case?
It would be R and then R minus 33.
Correct. So I'm going to multiply both sides times R minus 33. Okay. On the left side of the equation, the R minus 33s will reduce out, leaving me with 5R. On the right side of the equation, the R in the denominator will cross out one of the R's in the numerator, leaving me with 6 times the quantity R minus 33. Distributing then, I get 6R minus 198. I'm going to solve for R on the left side of the equation. So I'm going to subtract 6R from both sides of the equation, which will give me negative 1R equals negative 198. I'm going to divide both sides by negative 1. So now positive R equals 198. Let's see. What is R? That's rate in miles per hour, right? So that means the Chevy travels 198 miles per hour. The Dodge would be 198 minus 33, which would be 165 miles per hour. The question said, find the top speed of each car. So the Dodge Charger, 165, the Chevy Corvette, 198 miles per hour. Any questions on that? All right. New problem. Let's see here. This says boating. A boat travels 18 miles per hour in still water, and it can travel 22 miles downstream in the same time as it takes to travel 14 miles upstream. Find the speed of the current in the river. So let's see, what have we got? We've got a boat travels 18 miles per hour. That's a rate. 22 miles downstream, that's a distance. In the same time, that's time. So this is a distance equals rate times time problem again. Okay. So distance equals rate times time. Well, let's see. It says a boat travels downstream, same time it travels upstream. So we've got downstream and upstream. Okay, now let's get away from this specific problem for just a minute and let's think about how things work. Let's say you are out on a lake. There is no wind, there is no current, it's very calm, and you're in a rowboat, okay? Let's say that you are capable of rowing this boat 5 miles an hour, okay? So you're sitting in the boat and you're rowing along and you're moving at 5 miles an hour, okay? Now, let's say that you row in this lake over to where there is a stream that is coming into the lake, all right? And let's say the current of that stream is moving along at a rate of 3 miles per hour, okay? And you decide that you're gonna row, you wanna explore what's up the stream, so you're gonna row up the stream. Now remember, you're capable of rowing 5 miles an hour in still water. You are now going to row up this stream, and the stream has a current of 3 miles an hour. So you're rowing upstream at 5 miles an hour. The stream is coming down at you at 3 miles an hour. What is your actual speed up the river, up the stream?
Would it be 8 miles an hour?
No,
Or 2 miles an
the
hour?
stream's going against you. You're going 5 miles an hour, and the stream is coming at you 3 miles an hour.
So 2 miles?
How'd you get that?
You just subtract them.
So 5 minus 3 is 2, right? So your speed going upstream minus the current, which is working against you. So you're only going actually 2 miles per hour up the stream. Okay.
Yes.
Now, you get upstream, you get out of the boat, you dock, you have a picnic, whatever. You decide you're ready to go back home. You get back in the boat, and again, you row 5 miles an hour in still water, but now you're traveling downstream. How fast are you going now?
So we don't know how many miles an hour it's going downstream?
It's the same stream. It's traveling. The stream is moving at the current's going 3 miles an hour.
But you're working with it instead of against it this time?
Yes.
So
Yes.
you're gonna add them and get 8?
Exactly. Okay. Does that make sense?
Yes.
So going against the stream, it's hurting you. Going with the stream, it's helping you. Another example. You ever ridden an escalator?
Yes.
Yes.
Let's say that you're capable of walking 3 miles an hour, okay? And the escalator is moving at a rate of 2 miles an hour. Now, if you get on the escalator, let's say you're at the top of the stairs and you get on the down escalator and you just stand on the escalator. What did I say? It went 2 miles an hour. Okay. So how fast would you be going just standing on the escalator?
2 miles.
2 miles an hour. Okay. What if you're impatient and instead of just standing there, you walk your normal pace of 3 miles an hour and you walk down the escalator that moves at a rate of 2 miles an hour? Now, how fast are you moving?
5 miles per hour.
Right. Okay. Now, you're going to be naughty. You're going to go the wrong way. Have you ever done that on an escalator as a kid or maybe as an adult? You went up the down
Yeah.
escalator or down the up
Yes.
escalator? Okay. So we're going to go down the up escalator. We're going to walk down at a rate of 3 miles an hour and the escalator is moving at us at a rate of 2 miles an hour. How fast are we going?
1 mile per hour.
Right. Okay. Now, there's an expression and there's a song from the past that describes this whole situation. In fact, my daughter and I were talking about this very song. It's by a guy named Bob Seger and it's called Against the Wind. Have you ever heard it? It's like, running against the wind, you know, great voice imitation there. Basically, he's saying, you know, life sucks, then you take a math test and then you die. It's all bad. That's what he's saying. Against the wind. Everything's against him. It's pushing against him. Okay. Then there's an expression, go with the flow. What does that mean? To go with the flow. Nobody knows what it means to go with the flow?
To just like, I don't know, go with the flow.
You take the easy way. You just get in the lane and it takes you along, go with the flow. Okay. So going with the flow, you're not against anything. It's just carrying you along. Going against the wind, it's against you. So going up the down escalator, it's against you. Going the same direction, it's going to help you. So back to our escalator, going with the flow, it helps us. Going against it, it hurts us. The boat going with the flow, it helps you. Going against the current, it hurts you. All right, what does all that have to do with anything? Well, let's go back to our actual problem. Okay, in case you were wondering if I'd forgotten. A boat that travels 18 miles per hour in still water. So this boat, it must have a motor on it or some really strong rowers, is capable of going 18 miles an hour in still water. That means with nobody helping, nobody hurting. It can travel 22 miles downstream in the same time as it takes to travel 14 miles upstream. Find the speed of the current in the river. Okay. What do we know about the times?
They're the same.
They're the same, aren't they? Just like the last problem. How fast can the boat travel in still water? Do you remember?
18
Was
miles.
it 3
18.
miles?
So going downstream, it's going to be going 18 plus the speed of the current. Okay. Going upstream, it's going to go 18 miles an hour. What?
Minus the speed of the current.
Correct. Going downstream, you're going with the flow. The current is helping you, speeding you up past the 18. Going upstream, the current is against you. It's pushing back at that 18 miles an hour. So you're going to subtract it. So we're starting out at 18 miles an hour. Downstream, we're adding the current. Upstream, we're subtracting the current. okay? Now, distance equals rate times time. If distance equals rate times time, divide both sides by rate, time equals distance divided by rate. Time equals distance divided by rate. So the time downstream is 22 divided by 18 plus R. The time upstream is 14 divided by 18 minus R. Since the times are equal, our equation becomes 22 over 18 plus R equals 14 over 18 minus R. Okay? You got the picture?
Yes, sir.
So our LCD is going to be what? 18 plus R times 18 minus R. And over here, 18 plus R times 18 minus R. On the left side, the 18 plus R on the top reduces out with the 18 plus R on the bottom. And we've got 22 times 18 minus R. On the right side, the 18 minus R on top reduces out with the 18 minus R on the bottom, and we've got 14 times the quantity, 18. Whoops, excuse me, I messed that up. I can't walk and chew gum at the same time. Guess I better stop chewing gum then, or something like that. Let's see, this would be 14 times 18 plus R. Okay, so now distributing. Let's see, what is 18 times 22 is 396 minus 22R equals 14 times 18, which is 252 plus 14R. I'm going to solve for R on the right this time because it doesn't really matter. Okay. I'll add 22R to both sides. 396 equals 252 plus 36R. Subtract 252. Let's see, what's that going to be? That's going to be what, 144? Is that right? Divide both sides by 36, and R equals 4. Now, the question said, find the speed of the current in the river. Remember, R was the speed of the current, wasn't it? So what units would go with that?
Miles per hour.
Right. So current, speed, 4 miles per hour. All right with that?
Yes.
Okay, and another problem coming up. We good to go on?
Yeah.
Comparing investments. An amount of money invested for 1 year in a savings account will earn $1,500. That same amount of money invested in a mini mall development will earn $6,500 interest in a year because the interest paid is 10% more than that paid by the savings account. Find the rate of interest paid by each investment. All right, so we've got an amount of money invested, that's principal. We've got for 1 year, that's time. It earns $1,500, that's interest. It says, let's see, because the interest paid is 10% more, that's a rate. So we've got what, I equals PRT, interest equals, let's see, principal times rate times time. Do you see why it's that formula, not distance equals rate times time?
Yes.
Okay. So basically the first thing we're figuring out is what formula we're using. So I equals P times R times T. Let's see. We've got a savings account and a mini mall. A question that you might ask is, if the mini mall pays 10% more than the savings account, why would you invest in a savings account? Well, in the real world of investment, if there's a higher rate of return expected, there's often a higher risk of losing it, right? So maybe the savings account is guaranteed, whereas the mini mall is, you know, a risky business. Just anyway, okay. Now, an amount of money invested for 1 year in a savings account. So the savings account, the time is 1 year. It will earn $1,500. So that would be the interest. Okay. That same amount of money invested in a mini mall development will earn $6,500 interest in 1 year. So again, the time is 1 year, but now the interest is $6,500. Okay. Because the interest paid is 10% more than that paid by the savings account. So if the interest rate for the savings account is R, the mini mall would be R plus, now 0.10. What did I do? I converted the percent into a decimal number, because in this equation, we're not going to have them written as percents. Okay. I don't know anything about the principal. But yes, I do. It says an amount of money invested for 1 year in a savings account will earn $1,500. That same amount of money invested in a mini mall development will earn $6,500 interest in 1 year. So the principals are equal, just like in the last problem, I think it was the time that was equal. Okay. Now, if I equals PRT, and we want to solve for principal, we'll divide both sides by the rate times time. So the principal equals the interest over the rate times time. Okay. So the principal equals the interest, 1,500, divided by the rate times time. R times 1 is just R. The principal for the mini mall would be the rate, or excuse me, the interest, I, 6,500, divided by R times T, which is R plus 0.10, times 1, which is still R plus 0.10. So since the principals are equal, my equation becomes 1,500 divided by R equals 6,500 divided by R plus 0.10. Are you seeing this pattern? In each situation, we've got a fraction equals a fraction. So then we're going to multiply both sides by the LCD, which is what?
R and then R plus 0.10.
Okay. So on the left side of the equation, the R's reduce out, and we've got 1,500 times R plus 0.10. On the right side of the equation, the R's plus 0.10 reduce out, and we've got 6,500 times R. Distributing the 1,500 on the left side, we get 1,500 R plus 150 equals 6,500 R, because 1,500 times 0.10, you move the decimal point over one place. Subtract 1,500 R from both sides, you get 150 equals 5,000, oops, 5,000 R. Divide both sides by 5,000, and R equals, let's see, if we take 150 divided by 5,000, we get 0.03, which would equal what, 3%? So if R is 0.03, R plus 0.10 would be 0.13. So find the rate of interest paid for each investment. The savings account would be 3%. The mini mall would be 13%. All right with that?
Yes.
So we've looked at problems involving rate, distance, and time, where there were just two cars racing against each other. Then we looked at a situation where with a boat where it was going against the current and with the current. So we subtracted or added the current to the speed of the boat. And then we've looked at simple interest, and we also looked at some number problems. So tonight, let's see, this is what, Monday? Is this Monday? Yeah. So you're going to do 7.7 and the chapter review. Tomorrow during class, I'll answer questions from section 7.7 in the chapter review. Wednesday, there'll be no class meeting. You'll just take your test finishing by 11:59 p.m. Wednesday night. Do you have any questions before we dismiss?
No, that's it. Thank you.
No, thank you.
All righty.